Okay, so this is, excuse me, this is the application that I use to actually draw out explanations when a student comes into the classroom and he asks for, or she asks for, an explanation of some mathematical concept. I open this application up. It's actually already open. I just shared the screen so that the student can see this, and I explain the concept. And usually mathematical concepts are explained with pictures, largely with pictures. So the first thing I'll do when a student comes in is I'll ask the student for his birth date and his first and last name, or her first and last name. And I record that, and that's how I keep track of who comes into the classroom and what concepts that I help them with. Now I put that birth date and the first and last, just the initials of the first and last name, in the upper right hand corner of this video. And the reason I do that is because I'm going to edit the video and I'm going to put marks in it. The video is going to stop at the beginning of each new person's lesson, and then I will post the time in the video that each lesson begins. And in that way, students will be able to find their lessons very easy. Anyway, so I'm going to use my birth date and initials so you'll see what I do. So I would put a birth date here and initials, MR. And that's my birth date, December 29th, 1961. And my name is Mark Russell, so those are my initials. And that would indicate to me that this is the lesson that I gave to this person who was born on that date and has those initials. Hopefully that's enough to identify students uniquely. Anyway, now I'm going to show you a little lessonette so you get an idea of what a lesson looks like in this application. What I'm going to do is, suppose a student comes in and asks, y is m and y equals mx plus b always the slope of the line y. And this is a typical question that students in pre-algebra, sometimes Algebra 1, have. They learn about this form of the equation of the slope of a line, and they don't understand why it's always m. This m is magically always the slope. It's not magic. I'm going to show you exactly why. So remember, how do we define slope? We define slope as the change in y values divided by the change in x values. Now these symbols right here, these triangles, these are not triangles. These are Greek uppercase delta. That's a Greek letter, delta. And in mathematics, delta always means change, either a large change or a small change. The uppercase delta means a large change, and the lowercase delta, which looks like that, means a very, very, very small change, a change so small that it approaches zero. That's for a later date, that's for calculus. Anyway, how do we find these changes? Well, we choose 2 points. We choose a point 1 that is an x1, y1, and a point 2 that is an x2, y2, such that both of these points are on the line, or that they satisfy this equation. So in other words, if we replaced x1, whatever number x1 is, in x, then we would get y1 as the output. That would be our y1. Similarly with x2 and y2. Then the change between them would be the difference in the y values divided by the difference in the x values. Okay, and notice that the subscripts 2 on the y and the x are both first, and the subscript 1 on the y and the x are both second. Now, this doesn't tell us that ym is the slope. This just tells us what the slope is if we have the numbers for x1, y1, x2, and y2. But I can rewrite the numerator. Of course, y2 is the output that I get when my input is x2. So I can replace this y2 with this. And then similarly, I can replace y1 with the equation that I evaluate to get y1. And then, of course, that is all divided by the difference between the x's. Now, what is that? I'm going to simplify that numerator. And to begin with, I merely need to remove the parentheses from the first term. They don't make any difference. I don't need them. But in the second term, that minus sign, this right here, this minus sign, means change the sign of both of these terms inside the parentheses. And I get minus mx1 minus b. And again, that's all over x2 minus x1. Now notice the b, here I have a positive b and a negative b. And basically what I'm doing is I'm adding these two. Okay. If you don't understand that that's what I'm doing there, I have a positive b and a negative b and I'm adding the two, then that's a lesson for another day, but you should understand that. But that's 0, right? The sum of any number in its opposite is 0, so I'm left with mx2 minus mx1 over x2 minus x1. Now, what I'm going to do with this numerator is I'm going to apply the distributive property, right? Distributive property. And this is one of the properties of the set of real numbers and other numbers as well. If you don't remember the distributive property, please go look it up. I don't want to tell you everything. I do want you to do some work on your own. So, but what I get, essentially what I do is I factor out the m in each term, and I get m times x2 minus x1, and maybe you can see now how that is the distributive property. I'm going to go ahead and put the denominator in parentheses as well. But what do I have here? I have m times 1, because x2 minus x1 is just some number. Here we've already decided x1 and x2 are numbers, and x2 minus x1 is a number, and it's the same number in the numerator as it is in the denominator. So I'm dividing a number by itself, and that's 1. And that leaves m. So m, this m, is the same as this m. And it's always. That's what we get every time we do this. And you should see that simply by the fact that I didn't put any numbers here. I just used the abstract terms. So that is a way in mathematics that we show that some statement or some claim is true. Okay. So that is a little mini lesson, a lessonette. That's what a student will typically see, something like this, whatever the question is that they've asked. And then this will be edited really only to put stops where one lesson ends and another lesson begins. And like I said, I will make a document that says which student comes after each stop, so students can easily find their own lesson and watch it as many times as they want. You can download it from YouTube. I will give you a secret tip on how to do that, and I don't have a problem with you downloading it to watch it, although, you may want to leave it on YouTube and go to YouTube and watch it. It's probably cheaper than storing it on your own computer. Okay, so I'm going to stop this now, and then go now and watch the video of the actual classroom, and I'll explain some more about how the classroom works and what I do with these videos afterwards. Okay, and thank you.